When performing insertion tasks such as putting a key into a lock or dishes into a cupboard, humans often wiggle their hands and fingers to aid insertion. However, today's robots typically rely on detailed contact models, open-loop wiggling processes, and handcrafted sequential procedures. We propose a method of emulating the wiggling strategy observed in humans and demonstrate it on key insertion. A key is grasped between two GelSight Mini sensors, which provide a source of compliance and strain measurement during insertion. We then apply an Extremum seeking control law, which sinusoidally perturbs the 6 degree of freedom pose of a robot arm's end effector. The sinusoidal perturbations cause the key to press periodically into the lock, resulting in strain on the GelSight Mini pads. Internal cameras observe the strain as optical flow on the grasped key. The goal of the control law is then configured to minimize strain while maximizing insertion depth. A standard classical Extremum seeking controller is applied, consisting of a high-pass filter to remove the DC component of the objective signal, demodulation to determine the sign of the gradient, a low-pass filter, and an integrator that implements first-order gradient descent on the objective function. Here, the success rate and mean insertion time for each lock during two separate experiments is shown. On average, the algorithm achieves a 71% success rate over 120 randomly initialized trials with uncertainty in both translation and orientation.
A baseline method, CMA-ES, that relies on sampling instead of wiggling, achieves poor performance in 1 degree of freedom orientation perturbations, and fails almost all trials with 6 degree of freedom perturbations. When using vision to place the key at the lock opening, we achieve a slightly higher average success rate than when assuming random 6-off perturbations at the keyhole. In an evaluation on Automate, a state-of-the-art robot assembly benchmark, our method achieves a zero-shot 98% success rate, outperforming all versions of the baseline which were trained on the assemblies.
Thank you.